All right, today we're going to talk about radical expressions and rational exponents again. So section 8.6 extended. Again, kind of looking at it a little bit more. Going through a little bit more of some difficult problems in some sense of where your homework is like a little bit more. But again, a radical expression, remember, is like the same thing as a square root. And then a rational exponent is the same thing as like a fraction exponent. And those would actually be the same thing. So the square root of x is the same thing as x to the 1/2 power. Okay, because the square root's like a 2 there, and then the invisible exponent of a 1 there. So when I divide that, I get x to the 1/2. Okay. And again, that's what we're going to be focusing on today. If you recall, I think most of us struggled with the numbers part. I think the variables we did pretty well because you just really have to divide them. It's those numbers where some of us struggle on. For example, the fourth root of 81 means what times itself 4 times is 81. Well, the fourth root of 81 is 3. Okay, and then I have the fourth root of x to the 8th. Well, to find the fourth root of a variable, you're just going to divide. So that's really like saying x to the 8 over 4. Well, 8 over 4 is 2. I get 3x squared there. All right, and I feel like the variables we did really well on. It's just those numbers we have to kind of remember. And then rationalizing the denominator. That was kind of probably the tougher thing. When I have a cube root, I have to make sure I multiply it 3 times in the denominator. If I have a fourth root, I need to multiply it 4 times. If it's a fifth root, I need to multiply it 5 times. Square root, just twice. Okay, and that kind of eliminates that and leaves me just with that number itself there. Here's kind of a nice little flow chart to help you maybe recognize it. So it kind of shows you here square roots, cube roots, how they are compatible. It's like the nth root of a is the same thing as a to the 1 over n. That root goes to my denominator when I'm talking about rational functions. Okay, and they kind of show it over here as well with the nth root of a to the m is the same thing as a to the m over n. And then again, they use it with numbers as well. The cube root of 5 to the 6th is the same thing as 5 to the 6 over 3, or 5 squared, which is 25. All right, being able to take it basically step by step and solve this makes it a lot easier, really. If you try and do it all in one, it makes it really tough. But if you can kind of break it down into some smaller chunks, it makes it a lot more feasible to work with. All right, so number 1 here. I want to simplify each expression, assume all variables are positive. So number 1, I have 2 squared times 2 to the 3rd. There's a couple different ways I can work this problem out. First off, when I multiply them and they have the same base, what do I do with my exponents? I add. So this is really the same thing as saying I have 2 to the 5th power, which 2 to the 5th power is actually, anybody? 32. Now, if I didn't want to add exponents, I could have just simplified first. What's 2 squared? What's 2 to the 3rd? 4 times 8 is still 32. Either way I work it out, I still get the same answer. Okay, and that's the nice thing about these problems. I can work them out a lot of different ways. I'm still going to get the same answer as long as I do the roots and exponents correctly. Number 2, I have the square root of 8x squared over 2x to the 4th. Now, I have a fraction here. I want to simplify the fraction first. So what is 8 divided by 2? 4. So I have the square root of 4 over what is x squared over x to the 4th? I get x to the 2nd. Because when I divide, I subtract exponents. So I get x to the 2nd. And now I simplify that. What's the square root of 4? Square root of square root of x squared. I get 2 over x. Okay. Yes, sir.
Since you're dividing, when there's still being x in the top.
But I'm subtracting them. Remember when I divide, I subtract exponents?
Okay.
Because that's like I have 2 x's up top, 4 on the bottom, 2 of them cancel out. Number 3 here. I have the square root of 25x squared, all to the 3rd power. Take this step by step. What's the square root of 25? Square root of x squared. So I have 5x to the 3rd power. Well, what's 5 to the 3rd? 125. X to the 3rd power. So I get 125 x to the third then. And again, take these problems step by step with respect to radicals and exponents. They're not as bad. When you try and do them all in one, it kind of gets really ugly and nasty. But take it step by step. It's not that bad. So let's move on to the rational exponents here now. I have 9 to the 1/2 power. Well, 9 to the 1/2 power, what is that similar to in radical form? Yeah, this is the same thing as the square root of 9. And we all know the square root of 9 is actually 3. That's it. Number 5, 8 to the 1/3 power. What is the same thing as 8 to the 1/3 power? That's the same thing as the, what'd you say? The cube root of 8. Nice job. Again, that denominator is what goes as my root number there. So I have to get the cube root of 8, and the cube root of 8 is what, Sean? 2. Thank you. 2 times 2 times 2 is in fact 8. Number 6, I have x to the 8th to the 1/4 power. When I take a power to a power, what do I do with my exponents? I multiply. So 8 times 1/4 really gets me x to the 2nd power. Because again, I'm taking 8 times 1/4. So it's like 8 over 1 times 1 over 4. And I multiply those. All right. Now, number 7. Now we have kind of a little bit tougher rational exponent. I have 25 to the 3/2 power. Well, that would be like saying what? Does anybody know how to rewrite that? The square root of 25 cubed. Yep. My root, or my denominator goes to my root. My numerator goes to my exponent, and I break it down. Okay. So the square root of 25 is 5. I get 5 cubed. 5 cubed is 125. Nice job. Again, the biggest thing on these problems is being able to kind of break it down to radical form and to simplify it. Yes, sir?
So what did you make it the 2?
I did. All right, so the question was, what happened to the 2, right? Is that what your question was? So this 2, oops, wrong one. When it's a square root, it's an invisible root. I don't need it. Just like saying, like this is a square root, I don't need that 2 there, though, technically. And that's why I don't need to put it there, because it's kind of implied in the square root. Just like saying if I have like a 9, well, I don't need to put a 9 to the power of 1, it's that invisible 1. So the basic square root is invisible too.
But so the numerator would be the 3, would you have to bring over?
Yeah. Yep. So number 8 here. I have 8x to the 6th, all to the 1/3 power. How could I rewrite that? What did you say? Oh, that is the answer. How do you rewrite it as a radical, though? 1/3 power, right? What's the same thing as a 1/3 power? That's a cube root of 8x to the 6th. That's just saying the cube root of 8x to the 6th. And then the cube root of 8 is 2. Cube root of x to the 6 is x squared. I get 2x squared. All right? Take a couple seconds, try number 9. Number 9 is a lot like number 7. The only difference is it's a fraction. You have to do it to both the numerator and denominator. But take a couple seconds, try number 9. All right, let's look at number 9 here. Who thinks they got the answer? John. It is 8 over 27. Nice job. Okay. I would break this down. This is really the square root of 4 over 9, all to the 3rd power. The square root of 4 is 2. The square root of 9 is 3. So I would take 2 to the 3rd, or 2/3, all to the 3rd power. 2 to the 3rd is 8. 3 to the 3rd is 27. Again, this is one of those problems. Take it step by step. Don't try and all compact into one. Just go step by step. Take the square root first, or the cube root, whatever it is, and then square it or cube it and do the rest of it. Okay. All right, let's try number 10 here. Now this, again, these problems look like they're really rough. If you take it step by step, they're not going to be that bad. Number 10. When I multiply and I have the same base, what can I do with my exponents? I add them, right? So what's 3 halves plus 5 halves get me?
8 halves, 4.
So that gives me 4 to the 8 halves. Well, 8 halves is really 4 to the 4th. And does anybody know what 4 to the 4th is off the top of their head?
16 times 16.
Nice job. That's good work.
Yeah. What's that? 36, 1000.
Nope. 256. That is 256. Did everybody hear the way he did it, though? 4 to the 4th is the same thing as 4 squared times 4 squared. So he went 16 times 16. You went 4 times 4 times 4 times 4, which is the same thing. Either way you get it, you actually do get 256. But 16 times 16, some people sometimes more better than 64 times 4. Either way, you work it out. Nice job. Number 11. 27 to the 4/3 over 27 to the 2/3. Well, when I divide, what do I do with my exponents? I subtract. So that's the same thing as 27 to the 2/3 power. Try that one. Finish that one from there. 27 to the 2/3 power. Solve the rest of that one on your own. So yeah, if you rewrote this one, you should get the cube root of 27 squared. Cube root of 27 is 3. 3 squared is 9. All right. Now, number 12. Problem like this, there's a lot of different ways to do it. Multiple ways to do it. I could do parentheses first and then take that to the 1/2 power. Or, when I take a power to a power, what do I do with my powers? Power to a power, I multiply. So I'm going to do the power to the power. So what is 2/3 times 1/2? 2/6, right? So that's the same thing as 125 to the 2/6, which is really just 125 to the 1/3. Does everybody agree 2/6 is 1/3? So 125 to the 1/3 power is nothing more than the cube root of 125. The cube root of 125 is 5. And again, I could have done that a couple different ways. I could have taken the cube root of 125 squared, and then taken the square root, and I still get 5. Okay? Yes, sir?
How do you find the cube root?
Cube root means what times itself 3 times. So, if you can kind of see the numbers, for instance, I always tell students, if it ends in a 5, what number is it probably going to be? Something with a 5. No, I mean, yeah, you can guess and check on it. Like, you always want to start at low numbers, because when you start multiplying it by itself, they get high pretty fast. Like 5 times 5 is 25. But then times 5 again is 125. Times 5 again is 625. Like, they get high pretty fast. Like even 2, after you double it after a while, it gets pretty high. So I'd always start at low numbers like 2, 3, 4, 5, 6. Start somewhere down there usually. You don't have a lot of numbers higher than that. 13. Now 13. 27 times 64 to the 2/3. Some people earlier today were like, man, I don't want to do 27 times 64. What can I do with this exponent though? Can I just distribute the exponent to both of those? Well, if I distribute the exponent to both, I really have 27 to the 2/3 times 64 to the 2/3. Well, that's a heck of a lot easier than having to actually multiply them. So do 27 to the 2/3 power times 64 to the 2/3 power. Break them both down and solve that one. All right, so let's work it out here. 27 to the 2/3 power is 9. 64 to the 2/3 power is 9 times 16 is 144. And there's our answer. 144. Okay. 14. 1 over 243 to the 1/5 power. Now 1/5, that's like the same thing as the 5th root of 1 over 243. Well, what's the 5th root of 243? Again, things start low numbers. It is 3. And again, think about what it ends in. It's not an even number, so it's not going to be a 2. The next one I'd try is a 3. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So I actually get here 1 over 3. Okay. 15. 64 to the negative 1/3 power. What do we do with negative exponents? We have to move them, right? If it's negative on top, like you can write this as 64 over 1, right? If it's negative on top, I have to move it to the bottom. So this is the same thing as 1 over 64 to the 1/3 power. And then what is 64 to the 1/3 power? It's the same thing as the cube root of 64, which is 4. So I get 1 over 4. Nice job. All right, try all of number 16 on your own now. Try all of number 16. We're going to cross off 17 and 18. But try all of number 16 on your own.
Let's go with 3ix to x squared.
So close. I get the cube root, right? Of negative 27 over, x to the 6th. Because it's a cube root, I can have a negative underneath the radical. Because what times itself 3 times is negative 27? Negative 3. So it actually is negative 3x squared. If it was a square root, though, you'd be right on track. But because it's a cube root, I can't have a negative. Does that make sense? Because negative 3 times negative 3 times negative 3 would actually get us a negative 27. Okay, good work. All right, last couple. Try all 5 of these on your own. Either way you work them out, whether you want to simplify first and then do roots, or roots then simplify, either way, work all 5 of these out.
It's not me. I need to make it me. So it is.
All right, number 19 here. 5 squared to the 2nd power. What do you get, Jarrett?
25. 5 squared.
5 squared is 20,
25.
625. Yep. Because you get 5 squared, 25. Then you take 25 squared, which is 625. Or if you wanted to, you could have just said 5 to the 4th, which is the same thing as 625. Number 20. 8x to the 3rd over 27, all to the 1/3 power. Jack, what are you saying?
X over 3x.
So close. It's actually 2x over 3. Because the 1/3 power, again, is the same thing as the cube root. So the cube root of 8x to the 3rd over 27. Cube root of 8 is 2. Cube root of x to the 3rd is x. And then cube root of 27 is 3. So x stays on top. Number 21. Square root of 8x squared over 2x to the 4th. Mark? That is 2 over x. Nice job. Because that's the same thing as the square root of 4 over x squared, which is 2 over x. Number 22. John, what are you thinking here?
I just got it.
If I do this here, I actually get the cube root of 1/8, right? Which the cube root of 1/8 is 1/2. But then I have a 2 out front. So I have 2 times 1/2. 2 times 1/2 is 1. Why do I have a 2? You see the 2 out front? I think, did you forget to multiply by 2? I'm going to guess. Nice job. And number 3, Mr. Stefaniak. 125x to the 3rd. Nice job. Again, I would break it down. Square root of 25 is 5. Square root of x squared is x. Then I take 5x all to the 3rd power. And that's where we get 125x to the 3rd. Yes, sir.
Is it just because you cancel out with 3 and then you have the square root over 2?
What do you mean?
I'm not sure. Like, I just kind of waved it off, but I actually did more than 2 feet.
Like this 2?
Yeah.
That's because I had a 2 right there.
I actually did 2.
Okay, I was going to say, like, no, there's a 2 out front. Yeah, that's why I multiplied by 2. Here's your assignment.